Okay, so again, we'll come back and write our objective after we go through a couple sample problems, and then we'll add to what we're doing. So these examples we're going to do, you need to be writing down right now, okay? So we're going to do some more solving equations. The directions are just going to, oops, let me go back to black. The directions are just going to say solve. So when we say solve, should the variable be part of the answer in these? Well, the correct answer is it kind of depends on what the problem looks like. So I have 4d minus 5 times the quantity d minus 1 equals 3 minus d plus 2. Okay, so we're going to do that problem first. So what do we need to do to solve this problem? Chris? Ooh, so very close. He said one little thing that wasn't quite right. Allison? The negative is also attached to that 5, so keep that in mind. So if you're having trouble visualizing that, then change this subtraction problem to an addition problem. If that's what it takes to help you remember what to do, do it, okay? But you're absolutely right. We are going to need to get rid of the parentheses. So we're going to have 4d, and now we're going to distribute. And a negative 5 times a d is going to give me a negative 5d. And then a negative 5 times a negative 1 is going to give me a positive 5. Now, is there anything I could do over on the right side while I was working on the parentheses on the left side? Spencer?
You can combine like terms and add 3 plus 2.
Yeah, if you notice, we have 3 terms on the right, which means I have some like terms I could combine. And 3 plus 2, remember the sign is always what's attached to the numbers, so I get 5 minus d. All right, so we go back to the left, and I notice, wow, there I have 3 terms. So again, we're going to look for some like terms. And this time it happens to be the d's. So we combine those up, and 4d take away, bless you, 5d is negative d, plus 5 equals 5 minus d. Okay, now, I'm going to show this problem at 2 levels. Level 1, I want to get my variables, for those of you who like to do this one step at a time, I want to get my variables together on the left, so I'm going to do the opposite of the guy on the right. So I'm going to add d to both sides. Now if I do that, I get something that says 5 equals 5. And the question is, what does that mean? I'm supposed to be solving for d, and d's not even there in the answer, so how do I provide an answer for something like this? Hold the thought. Okay, hold the thought. Now, if I was somebody who liked to do 2 steps at once, and I added d to both sides, and I subtracted 5 from both sides, I would get a different answer, but similar at the same time. I would get 0 equals 0. Okay? So both of those gave me similar type answers depending on which strategy I used to solve, but both of them gave me an answer that I'm not used to seeing. Okay? All right, let's try another one. And then we'll go back to our objective. No, we're not done yet. I said hold off on the answer. We haven't finished. So we've got 3q plus 6 minus 5q equals 8 minus 2q plus 1. All right, so this one I notice I have 3 terms per side, so I'm going to combine up like terms. So here I've got q's that I can combine up, and this side I've got constants that I can combine up. And you guys understand why I call that a constant? 8 will always be 8. There's no way to change 8 because there's nothing attached to them. Whereas with the variable attached, 3q will change its value based on what value I come up with for q. Okay. So when I combine up my like terms, 3q take away 5q is negative 2q. And then I write out the rest. And 8 plus 1 is 9. And this time I'm going to do both steps at the same time, showing that strategy. So again, I want my q's to go to the left, so I'm going to add 2q to both sides. And I want to get my constants to the right, so I'm going to subtract 6 from both sides. And what I get is the 2 q's cancel. I get a 0 on this side. And on this side, the 2 q's cancel, but I have a 9 take away 6 is 3. So neither of these answers look the way that they should look, right? None of them say this is what x equals, this is what q equals, this is what d equals. So what we're left with is how to interpret the answer. So let's go back up and write our objective. Interpreting solutions that are missing a variable. In both cases, in these problems, the variable was eliminated, which is the very thing we're trying to solve for. So let's go back. Looking at example 1, what do you think the answer would be when we get 5 equals 5 or 0 equals 0? Justin?
1.
Okay. The number 1 would work. So if I plugged 1 in, I get 4, 1 take away 1 is 0, 5 times 0 is 0, so 4, and over here I get 3, take away 1 is 2, 2 plus 2 is 4. I got 4 equals 4, so that, yeah, 1 works, okay? But is 1 the only answer that works? Ian?
I think any number could work because as long as they're the same, then they can cancel each other out no matter what.
If we've proved in our math that we're going to cancel out the variable doing our math correctly, he's right. Any number could work, okay? So they actually have a special name for this one. This is called an identity. Okay, so an identity is an equation that is always true for any value. So that's this question here. When I get an answer where the variable is completely eliminated and the answer I get is always true, 5 is always equal to 5, 0 is always equal to 0, that's called an identity, and I get all numbers, okay? So I'm going to skip over to the next page, and we're going to talk about identity for a moment. There's a couple ways that you can write the answer. You can write the answer, and you can simply say identity. And since the definition says that it's an equation that's always true no matter what value is substituted for the variable, you can say this is an identity. You could say all real numbers. And the reason why I limit myself to the real number system is because since imaginary systems or imaginary numbers don't truly exist, and I can't truly do math with them, okay? So we're just going to focus in on the real numbers. So I could say all real numbers. And then there's a symbol that we use that represents all real numbers. And it's a cursive R, a cursive capital R, and it looks something like that. So all three of those would be considered correct solutions for an identity problem, okay? So the key phrase to think about is when you get an answer, is that answer always true? Then you've just identified an identity problem. So does that make sense? Okay, Spencer says yes. Now, I also have, I'm going to share with you what the book wrote, and I'm going to tell you I have a teeny bit of a beef with it. Now, the online book, And by the way, guys, I'm going to just tell you right now, if you have forgotten your password and your sign-in code, all of that, you guys have to hit me up before 8 o'clock, okay? Because I can't keep answering emails after 8 o'clock. So you guys have to at least attempt your homework prior to 8 o'clock and get a hold of me, because then I gotta knock this out. Actually, it should be before 7, because 7 to 8 is our real big getting ready for bedtime for Tiana. So in the online book, they use this phrase. Infinitely many solutions. Now, the problem I have with this one is, for me, that goes more along the lines when we're solving a system of equations and we're trying to locate a point that two lines have in common. And so, to me, this answer goes better with ordered pairs. So I'm going to ask you to not use this one. When you're answering this particular one variable type question with one equation. Okay, I'm going to ask that you don't use that answer even though the book does list it. What I do want you to write is that either identity, all real numbers, the R symbol for all real numbers. Those would be my three options that I will accept. Does that make sense? You guys good with that? Okay. We will use infinitely many solutions when we talk about a system of equations. Okay? All right, so let's go back to this guy. So number 2, we got 0 equals 3. So my question is, when does 0 equal 3? So in other words, this is never true. Okay? So if we have something that's never true, what letter does never start with? N. So we're going to write our answers as no solution. Okay? That would be one option. And the second option, there's a symbol that means no solution, and you have to write it exactly right. And it's a 0 with a slash through it. Okay? That means no solution. So you can either write out in words no solution, or you can symbolically write it out using that 0 with a slash through it. Okay? Any questions on that? Okay. So I told you our notes. Well, that's the end of our notes.